I'm ready. Divya ma'am.
Yes, sir. Shall we start, sir?
Yes.
Good morning to all. Once again, I welcome you all to the 3-day knowledge sharing workshop on machine learning with Python using COVID-19 data analysis. Today, we have two classification algorithm, ID3 algorithm in decision tree and a random forest ensemble algorithm, and have hands-on session on these algorithm. Let's have an introduction about today's resource person. It gives me an immense pleasure to introduce the resource person of today's session. In the first session, ID3 algorithm in decision tree by Mrs. R. Kalaishelvi, Assistant Professor, Department of Computer Science Engineering, Arasu Engineering College, Kumbakonam. Ma'am did her PG in Prist University, Tanjore, completed UG in Government College of Engineering, Salem. Overall, 9 years and 6 months of experience in teaching. Her area of interest are machine learning, cloud computing, Internet of Things. Presented and published almost 15 papers in various conferences and journals. Ma'am organized 7 programs. Ma'am received Best Guide Award from IET. Whereas in the second session, Random Forest Ensemble Algorithm by Mrs. R. Sudha, Assistant Professor, Department of Computer Science Engineering, Arasu Engineering College, Kumbakonam. Ma'am did her PG in Periyar Maniammai University, Tanjore, completed UG in Periyar Maniammai College of Engineering and Technology for Women, Tanjore, completed a course in Advanced Internet Power Programming at Pentasoft Technologies, Chennai. Ma'am had overall 20 years of experience, more than 15 years of experience in teaching and 4.6 years in industry. Her work experiences are worked as a programmer analyst in Roshan Technologies Limited, Chennai, and a senior programmer in HM Infotech Limited, Chennai. Currently working as an assistant professor in the Department of Computer Science Engineering, Arasu Engineering College, Kumbakonam. Her area of interest are medical image processing, machine learning, Internet of Things. Now, I hand over the session to Mrs. R. Kalachelvi, ma'am. Kindly, ma'am.
Thank you, Divya, for the introduction about me. Good morning to all. Once again, I welcome you all to this wonderful workshop. First of all, I thank our management, Principal Sir, Vice Principal Ma'am, Dean of Academics Sir, our HOD Ma'am, and my dear colleagues for giving me an opportunity to share my knowledge in this wonderful 3-day workshop on machine learning with Python COVID-19 data analysis. I thank our beloved HOD ma'am who guided, supported and motivated me to take part as a resource person in this workshop. I thank Ms. Divya who always supporting me for this workshop. Now we move on to this today's session, decision tree along with case study. So we already discussed what is machine learning, what are all the types of machine learning in the previous sessions. So first of all, what is decision tree? Decision tree is one of the most powerful and popular machine learning algorithms. It is a non-parametric supervised learning method. That method is used for both classification and regression. Classification scheme which generates a tree and set of rules from the given data. So the set of records is available for developing classification methods into two subsets. One is training set and another one is test set. Training set is used to build the model and test set is used to determine the accuracy of the model. For the classification model, the target classes are discrete, and for the regression model, the target classes target classes or continuous. The attributes of the records are categorized into two types. So one is numerical, another one is categorical. So attributes whose domain is numerical are called numerical attributes. Attributes whose domain is not numerical are called uh, categorical attributes. For example, if you are going to take the loan applicant, a customer wants to apply the loan to the bank. The bank loan officer wants to analyze the data in order to know which customer are risky or which customer are safe. So, for example, if you are going to take the marketing manager, the manager wants to analyze the customer. That is, with the given profile, who will buy a computer or who won't buy a computer. So, in the above examples, model or classifier is constructed to predict the categorical labels. So, for loan application data, risky or safe are the class labels, and for marketing data, so whether the customer will buy a computer or not buy a computer. So yes or no are the class labels. So first of all, what is decision tree? Decision tree is nothing but it's a graphical representation of possible solutions to a decision based on certain conditions. That is, based on the certain conditions, we are going to make a decision. So it is a decision tree. It starts with the root node, then branches off into a number of solutions. For example, we can consider that as a person fit or unfit. So in that case, I want to take the decision for that condition whether the person is fit or unfit. If the person is less than 30 years of age, so does the person eat pizza means the person is unfit. So it starts the decision, that is the condition is starts from that root node, that is whether I want to find the person is fit or unfit. So it can traverse from that root node to that here the condition is to be checked. If the condition is satisfied, so the person is less than the age of 30, it can traverse to the left side of the tree. So does the person eat pizza means again that here the condition is to be checked. So in that case, here also the condition is to be satisfied. Again, it can traverse to the left side. So the person is unfit. Suppose if the person age is greater than 30 means, that is, it can traverse to the right side of the tree. So that is, again, we have to check the conditions. So the person can do exercise or not. So here we want to classify the class, that is either fit or unfit. Based on the conditions, we want to take a decision for that. We want to take a decision. That is called what? It is a decision tree. So decision tree is nothing but what? It is a graphical representation of possible solutions to your decisions based on certain conditions. So next thing is decision tree having some properties. That is, inner node represents attributes, and edge represents a test attribute of the further. A leaf represents one of the classes. So construction of a decision tree based only on the training data and then top-down strategy method. So for consider this, that is root node, decision node, terminal node, like that. So what is root node? So in that case, first it decides the sample data. So in that root node, if you are going to divide the data into two or more homogeneous sets, in that splitting is nothing but what? It is the process of dividing a node into two or more subnodes. What is decision? Decision node is nothing but that is, we want to decide whether or when a subnode can be split into further subnodes or not. Terminal node is nothing but what? It's a leaf node. So it always predicts categorical or continuous values. So categorical attributes or continuous attributes. That is numerical attributes. So the attributes whose domain is always numerical, we can call it as numerical attributes. Whose domain is not numerical, we can call it as categorical attributes. For example, if you are going to take, that is one training data sets will be there. So here 5 different attributes are there. That is, data sets having 5 different attributes. One is outlook, temperature, humidity, windy, and classes. So in that case, the special attribute class is a class label. Okay. So next, temperature and humidity or numerical attributes. Here all the values are only numerical, that is 79, 90, 56, 70. So all the values in that temperature attributes and humidity attributes are numerical, but outlook and windy are categorical attributes. So that values cannot be ordered. That values cannot be ordered. So next one is, based on the training data, we want to find the rules. We want to find the set of rules to determine what values of outlook, temperature, humidity, and wind to determine whether play or not. Okay, based on the training data, you are going to create the tree. That is how. So first, there is here 5 leaf nodes are there. So each leaf node represents what? That is rule. Each leaf node represents what? It's a rule. Okay. So we have the following rules corresponding to that tree. So given here. So if it is sunny, so the outlook is sunny and the humidity is not above 75%, which is less than or equal to 75% means then play. So if the outlook is sunny and the humidity is above 75%, so then don't play. So if the outlook is cloudy, then play. If it is rainy and not windy, that is, it can traverse to the right side of the root node. Rainy means, so in that case, that is, windy is nothing but what? It is the internal node of the decision tree. So that is, here we are going to take a decision, either wind is equal to true or wind is equal to false. So if wind is equal to true means, that is, don't play. Wind is equal to false means that we can play. So have you cleared in this example? Okay. Next one is classification of how the tree can be traversed from root node to leaf node. So normally an input vector is done by traversing the tree from the root node to a leaf. That is, it starts from every record enters the tree at the root node. So normally the test is applied at the root node to determine which child node the record will encounter next. So the process is repeated until the record arrives at the leaf node. All the records ends up at a given leaf of the tree are classified in the same way. So, for example, if you are taking this, the previous training data set, so here where the tree is there. So, let us assume. So, we know that the values of the 4 attributes, that is outlook, humidity, play, and then windy. So, outlook, suppose if we are going to take outlook is equal to rainy and cloud is equal to, that is temperature is equal to 70 and humidity is equal to 65, wind is equal to true. But we don't know the values of the class attributes. How we can find the values for the class attributes? So first of all, we want to start from the root node to check the value of the attribute associated at the root node. So the attribute is splitting attribute at this node. So that is, outlook is the splitting attribute. For a decision tree, at every node there is an attribute associated with the node called the splitting attribute. Associated with the node called the splitting attribute. So next thing is, so in our example, outlook is the splitting attribute. Outlook is the splitting attribute at the root. So here in that case, that is given record is equal to, the given record outlook is equal to rain and temperature is equal to 70. So outlook is equal to rain means the tree can traverse to the right side. The tree can traverse to the right side. So at this node, that is windy is nothing but here splitting attributes. So tree is equal, that is outlook is equal to rainy. The tree can traverse to the right side of the root node. So normally traversing to that right side. Wind is equal to true means, so it can gives that class as don't play. Suppose wind is equal to false means it can give the class as play. Okay. So this is called what? It's the numerical attributes for classifying this. So for next, categorical attributes. Here, three different attributes are there. One is age, pin code, and class. So in that case, age is nothing but what? It's a numerical attribute. Age is nothing but what? It's a numerical attribute. And class is nothing but what? It's special attributes. Okay, class is a special attribute class. So pin code is what? It's a categorical attributes. That pin code is, though the domain of pin code is numeric, but cannot be ordered, can be defined among the pin code values. Okay. So in that case, for if I want to create a decision tree from the given set of data, so how to create the tree? So pin code is the root node. In that case, that is the splitting criterion for this root node is 395003. At this root node, that is 9 records are there. So 1 to 9 records are there. So the previous training data set, that is totally 9 records are there. That is totally 9 records are there. In that case, that is pin code is nothing but what? It's a splitting attribute at the root. That is splitting criterion is here the pin code is 395003. So for the left child, for the left child node, if age is less than or equal to 48, the here splitting attribute is age, but the splitting criterion is age less than 48. Splitting attribute is age and the splitting criterion is age less than or equal to 48. For the right side, so from the root node, the right child node, so same attributes, but the splitting criterion is different. So for the left and right node, the age is same. That is, splitting criterion is same, but the splitting attribute is same. The splitting criterion is different. Sorry. So splitting attribute is same. Splitting criterion is different. Age is same. So here the condition is age less than or equal to 48. Here age less than or equal to 21. Based upon this, we are going to classify the class labels. So based on the training data. So next we move to that ID3. That is in that classification algorithms, decision tree is one of the classification algorithms. So in that decision tree, different algorithms are there. That is ID3, C4.5, CAR, and chi-square automatic interaction detection. So ID3, the acronym for ID3 is iterative dichotomizer 3. So iterative is nothing but what? It's the repeatedly divides the futures into subnets. So it ID3 is invented by Rose Quinlan. ID3 algorithm is one of the most effective algorithm is used to build a decision tree. So ID3 uses top-down method, that is 3D methods are used. So in that each column in the data set is called what? Attributes. So data set, each column in the data set represents attributes. At every node, we can be tested. So if I want to select the best attribute for constructing a tree, so how can I select the best attributes from the given data set? So by using that ID3, so ID3 uses entropy and information gain. So based on the entropy and the information gain, you are going to select which attribute is best for creating a for constructing a decision tree. So first of all, what is entropy? So entropy is nothing but amount of uncertainty or randomness in data. So it is nothing but entropy is a controller for decision tree to decide where to split the data. So where to split the data and also when to split the data. So entropy uses to calculate, that is normally ID3 uses entropy to calculate the homogeneity of a sample. If the sample is completely homogeneous, the entropy is 0. If the sample is completely homogeneous, the entropy is 0. If the sample is equally divided, the entropy value which is equal to 1. If it is 0, the entire sample is homogeneous. If it is 1, the entire sample is divided into equal. Okay. So this is what entropy. So So one formula is there for calculating the entropy. We will discuss in that next slide. So for example, if you are going to take the COVID-19 training data set, so here fever, cough, breathing issue, infected or the attributes. So here that is 4 different attributes are there. That is fever, cough, breathing issues and infected. Class is nothing but what? Infected. So the class attribute is infected. So here some data will be there. That is totally 14 rows will be there in that training data set. So first I want to calculate the entropy. How? First entropy of there is one formula I already told. If the entropy value is 0, the sample is homogeneous. If it is 1, the sample is divided into equal. Okay. So entropy of S is equal to minus summation pi into log 2. That is 2 is nothing but what? That is class labels. For example, if you are going to take the training data in that previous that is training data in that class labels, there is two options only there, either infected or not infected. Based on this, we are going to give that that is log 2, that is pi. So where I is equal to 1 to n. So how many rows in the data set? So I already told that is 14 rows in the data set. So there are 8 rows. See calculated, 8 rows in the data sets are yes and 6 rows in the data sets are no. That is target class infected. 8 rows in the data sets are yes and 6 rows in the data sets are target values are no. How we are going to calculate the entropy of yes? So already we find that in that data set 14 rows, the 14 rows contains 8 rows target value x and 6 rows with target value no. So entropy of x is equal to minus summation of pi. So here the pi denotes the target value as yes. So 8. So out of how much? That is 14 rows. Okay. 8 by 14 into log 2. That is pi is nothing but 8 by 14. Okay. That is plus. Next one is that is based on the training data. 6 rows with the target value. No. Okay. So based upon this 6 by 14 out of 14 rows, 6 rows having the target value no into log 6 by 14 base 2. 14 is nothing but what? It's there are 14 rows in our data set. Okay. So 8 by 14 which is equal to 0.57 and 8 by 14 log base 2 which gives the negative value that is minus 0.807 and 6 by 14 0.42 and log 6 by 14 base 2 which gives the negative value. So here the common negative value which goes to that inside, that is negative into negative which will gives the positive values. Here also it will goes to the negative value, negative will goes to that inner side. So here also the negative into negative will get the positive value. So based upon this calculations, entropy of S is equal to 0.99. So see that if entropy is 0, that is the sample data is homogeneous. If entropy is 1, the sample data is divided into equal. See, which means our set is almost impure. Okay. So next one is I want to how to say that is pure set is 0 and how to say the pure set 1 if you are going to take 1. So see this. So entropy, totally how many rows in the data set? That is totally 14 rows in the data set. That is 14 rows as consider 14 rows as yes and 14 rows that is 0 rows are no. So 14 by 14 log 14 by 14 base 2, 0 by 14 log 0 by 14 base 2. So log 2 that is 14 by 14 which is equal to 1, that is log 1 base 2 which is equal to 0. So minus 1 into 0, anything values into 0 which gives us a value 0. Okay, next if the entropy value is 1, entropy value is 1, so we can calculate that. So 7 rows having S value and 7 rows having no value. Okay, so here in that case that is totally 7 rows are there. So out of 7 rows are yes in out of 14 rows. So 7 by 14 log 7 by 14 base 2 minus 7 by 14 log 7 by 14 base 2. So it will give that negative values for log 7 by 14 base 2, that is minus 1, and log 7 by 14 also minus 1. So the negative symbol which goes to the inner side, so it will get the positive value 0.5 plus 0.5, which is equal to 1. So this is the entropy for a complete pure set is 0 and is 1. Okay. So next part is information gain. How to calculate the information gain? We know the training data set, that is fever, cough, breathing issues, infected. So in that case, first I want to calculate the fever. First I want to take the feature as fever. So in that case, see the training data set. See the training data set, that is fever, that is infected part will be there. In that part, how many rows are yes and how many rows are no. So based upon this, we are going to calculate the information gain. First, I select that feature, that is feature as features fever. So 8 rows having value yes and 6 rows value having no. So based as shown below this data set, let us see this 8 rows. Based upon the 8 rows, that is 6 rows having that is infected and 2 rows having the target value as not infected. So I want to calculate the entropy value for this training data set. So how to calculate the entropy for this training data set? Entropy of S, fever is equal to S. Here the feature fever is equal to yes. I select only the data. So for fever only. So fever is equal to yes means here 6 rows having that is infected and two rows having not infected. Based upon this, I want to calculate the entropy minus 6 by 8. That is here totally 8 rows are there. 6 by 8 into log 6 by 8 base 2. Here also that is two things will be there. One is infected or another one is not infected. That's why I gave 2. So 2 by 8, that is 2 rows are not infected. That is 2 by 8 into log 2 by 8. So which is equal to 0.81. So the values which is equal to 0.81. Next, I can select the feature fever. So for feature fever, so I already told that feature fever that is 8 rows having a S value and 6 rows having what? No value. 6 rows having no values. So here, in that case, the 2 rows are that is from the given data set 6 rows. The 2 rows are infected. Remaining 4 rows are not infected. Okay, have you cleared in this infected class? There is class infected. There is 4 rows having not infected. 2 rows having infected. Yes, 1, 2. That is no 1, 2, 3, 4 like that. That is 2 rows having infected and 4 rows having not infected. So based on this, I want to calculate the entropy for this data set. How I want to calculate that? So entropy is fever is equal to no. So you have to give that fever is equal to no. I select only this data set. So based upon this, fever is equal to no. That is 2 sets having yes. That is 2 divided by how many rows? That is totally 6 rows. Log 2 by 6 base 2 minus 4 by 6. That is negative values can come inside. That is 4 minus 4 by 6 into log 4 by 6 base 2. Okay. So which gives the value as nearly 0.91. So entropy of fever is equal to fever no is equal to 0.91 and entropy of fever S is equal to 0.81. Okay, have you cleared in this? Okay, next. Okay. So here we are going to calculate only the entropy for the fever yes and the entropy for the fever no. So next one is I want to calculate the information gain for the fever. How? So what is the formula for this? So that is information gain of total entropy, fever is equal to entropy. I already calculate the total entropy values, which is equal to 0.99. So first one is if we were yes out of how many rows? That is 8 rows having fever. That is yes, and 2 that is infected. That is 2 rows having not infected. We already discussed. So 8 rows out of 14 rows. So 8 by 14 into entropy yes. What is the value of entropy yes? So we already find that value of entropy as 0.81. So here 0.81. So for the entropy, that is no. That is how many rows having no? That is 6 rows having no. And we want to out of how many rows? That is 14 rows. That is entropy of yes. That is entropy of yes no. That is for fever. We want to calculate it. That is fever no is equal to 0.91. We already calculate that entropy of fever is equal to no. This is the value for that. That is 0.91. Here we are going to put 0.91. So based upon this calculation, I'll get 0.13. So information gain for fever, which is equal to 0.13. So now the same way can be applied for calculating the cough and for calculating the breathing issues. So we can calculate the information gain for the features cough and breathing issues. So for the cough, which is equal to 0.04, and for breathing issues, which is equal to 0.40. So see these values, information gain for fever, which is equal to 0.13, and information gain for cough, which is equal to 0.04, and information gain for breathing issues is equal to 0.40. So here breathing issues have the highest information gain. So it is used to create the, so breathing issue is used to create the root. How can create the tree? That is the first initial state. So here breathing issue is the root node. So remaining two unused features are there. One is fever and another one is cough. We already find what is the value for cough and what is the value for fever. But in that case, so the highest information gain is what? That is breathing issue, that is 0.40. Based upon the value, we are going to create the root node for that. That is breathing issue is the root node. Remaining two unused features, namely fever and cough, we decide which one is the best for the left branch of breathing issues, or which one is the best for the right branch of the breathing issues. We want to calculate. So how we are going to calculate? So since the left branches is what? That is breathing issue. Breathing issue is yes. We can take breathing issue denotes yes. Okay, breathing issue denotes yes. So we will work with that original data. We go for that original data. In that data, if breathing issue is yes, so breathing issue S means that is set of rows will be there. So in that set of rows, totally 8 rows are there. So totally 8 rows are there. So based upon this data set, I want to calculate the breathing issue S and breathing issue no. Okay. So if breathing issue S means, so how many nodes are, how many classes are infected and how many classes are infected? Only 2 classes are infected. That is 2 roses are infected and remaining 6 roses are, only 2 roses are not infected and 6 rows are infected. Again, I will tell. So see the previous example, that is breathing issue. I want to find the remaining two unused features are there. I want to find which one is the best for the left branch of breathing issues and which one is the best for right branch of the breathing issues. I want to find. So based upon this, left branch of the breathing issue is yes. Okay. So we can take that the original data for original data. So the set of rows having that breathing issue, yes, there are. That is totally 3 plus 3, 6 plus 2, 8. Totally 8 rows are there. Okay. Now, so in that case, that is 6 rows are infected, 2 rows are not infected. Okay. Have we cleared in this training data set? Okay. Next. we want to calculate the IG for the features fever, cough. First, the set breathing issue is yes and fever is also yes. So we can calculate that breathing issue yes and fever is yes. So if you are going to take that, so here most of the values are yes. So, if we want to calculate the entropy value, so the time consumption is very less. So that's why I'm already calculating the values for that. Simply, I'm going to put the values for the information gain. That is breathing issue is for fever and breathing issue is for cough. We will get only the values that is 0.20 and 0.09. So normally if I want to construct a tree, so root node is greater when compared to that left child, and root node is smaller when compared to that right child. Root node is always smaller when compared to that left child. Root node is always smaller when compared to that left child. Okay. So in that case, fever is a less value. So I can place it in that left side of the root node. That is breathing issues. So again, I want to calculate either the class label I want to calculate here. That is either yes or no. So either infected or not infected. How? Next, we find the features, the maximum information gain. So for that, so here I already find the feature fever, that fever can be placed in that left side of the root node. Again, I want to find the right node. So how I want to calculate it, but there is only one unused features. So already we placed the feature in that left side. So there is no other choice for placing that right branch of the root node. So the possibilities is, so breathing issue is the root node and fever is the left child and cough is the right child. Okay. So again I want to calculate the, again I want to find the class labels for fever and then cough. How I want to find? So for the left leaf node, of fever, yes. Okay. So leaf node of fever. So see that data set. So breathing issue and fever is yes. See this. So here left side tree, here the breathing issue is the root node, fever is the left child. So if breathing issue is yes, so it can traverse to that left side. If the fever wants to classify either yes or no, I'll take both the values are yes. Okay, breathing issue is yes and fever is yes. So if both the values are yes, so I want to take the data set from the original data set. That is breathing issue is equal to yes and fever is equal to yes. So here see the infected class. Most of the almost all the rows are infected. There is no need to find the values for this. So here see the data set table, that is in that data set. So almost all the rows are infected. So we can label that left leaf node as L. So it's more logically that that is infected. That is more logically that is infected. See the right node of the fever. So in that right node of the fever, so that is we can select that breathing issue is yes and fever is equal to no. So see this, if there is most of the values are no, that is in that class attributes, most of the target values are no. So it becomes to that right leaf node, that is not infected. See the decision tree, that is breathing issue is a root node and fever is the left subtree. If breathing issue is yes, so we are it can traverse to that left side. So the fever is yes, both the breathing issue and fever is yes. So almost get the values is infected. So we can place we can classify that label as infected. If breathing issue is yes and class label next to fever is no, that class label is not infected. Okay. Have you cleared in this for the left side? of the decision tree? Okay. Excuse me, sorry. Okay, sorry for the distance. So next one is repeat the process, repeat the same process for the node curve. So again, I want to select the data set from that. Again, I want to select the data from the data set, that is breathing issue and a cough. So based on the data, so I want to find the class labels for that class. I want to find the class labels for that cough, that is either infected or not infected. If I am going to select the breathing issues, that is no, and cough is yes, the data sets will provide provides the class, that is most of the classes are not infected. So that's why we are going to place that. So either yes or no. So if you are going to take the data set, both the classes, that is for left for the cough left child and for the right child not infected is to be placed. Okay. So up to this decision tree, how we are going to create a decision tree based on the training data set. So normally decision tree, if I want to create the decision tree, so decision tree is based on the training data set and top-down strategy method is used. Okay. So the input vector, that input vector can traverse from the root node to the end of the leaf node. Okay. So any queries? Please post your query in the chat box. Fever also has cough. No, 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 no. The sir, fever, sir, I already see that. I took only the data set as that is, I took the data set, that is fever, cough, breathing issues, and infected. Okay, three different, that is totally four different attributes are there. It is here fever. If fever is there, that person can be infected. If cough is yes, the person can be infected. If breathing issues, if both the things are yes, then the person is infected. Okay. Okay, thank you. I hand over the sessions to. So thank you one and all. So I hand over the sessions to Mrs. R. Sudha ma'am.
Participants, kindly wait for a while. Thank you, ma'am. Thank you, Kalishwari ma'am, for your valuable time and for your presentation. Hope you all got a clear idea about decision tree. Wait for 2 minutes.
யாரோட உங்களுக்கு தான் கோவத்தை தானே வைக்கிறீங்க.
Sir. Kanan sir, screen share ஆகுதா sir?
ஓகே.
Slides move பண்றேன் sir. Share ஆகுதான்னு ஒரு வாட்டி பாருங்க sir. ஆகுதா sir?
ஓகே ஓகே ஓகே. You can.
Once again, I welcome you all. Now, the second session is going to handled by Mrs. R. Sudha ma'am. Kindly, ma'am.
Good morning to all. I welcome you all for this second session of this third day workshop, that is machine learning with Python COVID-19 data analysis. So the previous session, Mrs. Kalaichalam discussed about decision tree with case study. So here we are going to discuss about random forest ensemble with case study. So what are the topics we are going to discuss? That is ensemble learning algorithms, bagging and boosting, what is random forest, why random forest, and random forest algorithmic steps, examples, advantages and disadvantages, applications of random forest. So before we are going for ensemble learning algorithms, what is random forest? The random forest is a meta algorithm and it is a supervised learning algorithm. It is both for classification and regression in machine learning algorithms. So what is ensemble learning algorithms? The ensemble learning algorithms are meta algorithms that combine several machine learning algorithms into one predictive model in order to decrease variance, bias, and improving the predictions. So here in decision tree, it has low, it has high variance. So we are going to apply this decision tree algorithms into our random forest algorithm. So this algorithm can be of any machine learning algorithm such as logistic regression and decision tree, etc. So in this, what are the things we are going to applied in our ensemble learning method? That methods, that learning algorithms are called as Bayes models. That is Bayes learners in our random forest. So sequential, we are having two kinds of ensemble learning algorithms. One is sequential ensemble methods and the next one is parallel ensemble methods. In this sequential ensemble methods, where the Bayes learners are generated sequentially. That is, we are trying to add new models that do well where previous models lack. That is, in the previous models, we are having some error, means we have to correct that error and that output is fed to the input of the other learning model. For example, AdaBoost learning algorithms. So what is the main motivation of this sequential ensemble method is that to exploit the dependence between the Bayes learners. That is one output is dependent on the another one. That is the dependence between the Bayes learners. The overall performance can be boosted by weighting previously mislabeled examples with higher weight. So the next one is parallel ensemble methods. So where the Bayes learners are generated in parallel, for example, combining many models to reduce the variance. Example, random forest. In our random forest, the decision trees, we are creating different set of decision trees and combining all those decision trees to predict the final classifier. So what is the main motivation of this parallel ensemble method is that to exploit independence between the Bayes learners. That is, one is not dependent on the other output. Since the error can be reduced dramatically by averaging. The general idea is that in this model, so this is our original training data. This is our original training data. So we are creating multiple data sets. We are creating multiple data sets based on we are creating the multiple data sets based on the previous one. So these multiple data sets are fed to the multiple classifiers. That is, we are creating multiple decision trees based on the bootstrapping data sets. And the next one is we are combining all those predictions to the general classifier, that is combining classifiers. This will predict the final output, that is final class of the given original data. So there is bias variance estimation in this diagram. So what is the variance and what is bias? So the bias is contributed by the training error. That is a complex model, it has a bias, low bias. In variance, it is caused by future error. That is, the complex model has high variance. For example, in case of decision tree, it has high variance. So what is bias means it is expected error of the combined classifier or new data, and what is variance means it is expected error due to the particular training set that is used in our training model. So what is the total expected error means that is bias plus the variance values. So what are the conditions for ensembles to outperform the base model? So there are having two kinds of conditions. One is accuracy. So we have to train the Bayesian classifiers. It must outperform the random guessing. How we are outperforming the random guessing means, so we can label the different samples of the given data set by using the random guessing method. That is the final output. So if you are applying some condition to our training, that is your training model. So what is the final output? Either it is either 0 or B, or true or false, or yes or no. So this is the random guessing outperforming. It will be combine all of these base classifiers. That is, we are unification, or you are combining all these classifiers that result into a better accuracy and outperforms the best random guessing method. So the next one is diversity. So the model should not be identical, that is in classification or regression estimates. Whenever we are trying to build a model using random forest, take into account the different attributes or features offered by the different data sets. So in our original data set, we are having many number of attributes. So based on these attributes, we have to select some set of features, selected set of attributes in the given data set. And each of these base model can decide on their own what attributes we are going to pick. That is, in the original data set, what are the things we are going to consider. So what are the attributes we are going to select. But in case of COVID-19 data set, in the previous example, in the decision tree example, so cough, a breathing issue, something like that. So these are the, what are the parameters or what are the attributes we are going to pick, and make sure that the classification or regression model is giving the best accuracy. So each of these model is diverse from the other base model. So why the name is random? So random sampling of training data set when building trees. So we are taking the random set of sampling data. That is, based on the original data set, we have to construct many number of sampling data, that is bootstrapping data. How the bootstrapping is applied in our random forest, and how the random forest ensuring the model diversity. So we are having two kinds of behavior in the decision tree. One is bagging or bootstrap aggregation, and the next one is random feature selection. In what is bagging or bootstraps? What is bagging? So in this bagging, it is a bootstrap aggregation method that results that gives the low variance of the given original data. That is, we are splitting the data in random different ways. That is, different trees, that is decision trees give different results. That is, it provides the high variance in the decision tree. So it is a major drawback of the decision tree. So based on this high variance, we are applying this decision tree into our random forest. In our random forest, actually we are considering this entire data set. These entire data sets can be divided into multiple random subset of data. That is, dividing the data set into different random subsets based on some conditions. So these random subsets are applied to the different decision trees. That is, we are training the decision trees. That is the decision tree, that is the base learners. These decision trees are called as base learners. That is DT1, DT2, and so on, DTN. Using these random set of features, we have to split the different. We are constructing the different decision trees. So each and every decision tree can predict some result. So these results are combined into a final output, that is the bagging method. So first one, the first step is divide the training set into a number of sub-training sets. So each training set is used to train a decision tree. So based on this final output, we have the average of the prediction of all the decision trees is a final prediction. So this is our given example. So for example, it is bagging data. So in this original data, we are having some weighted values. Bagging down one, we have to get some bagging down one, what are the data we are applying. So first to build the classifier on each bootstrap sample. In this bootstrap sample, we are having a different set of data sets, that is a sample data set. Each sample has the probability of 1 by 1 minus 1 by n, the whole power n of being selected test data. So that is, if you are having total number of 3 means we have to collect 1 by 3. So what is our training data? 1 minus 1 by n, the whole power n of the original data. It works well if the base classifiers are unstable. Sorry. So it is, if it increases the accuracy because reduces the variance. What is our problem in decision tree? It has the high variance. But in our bagging method, we are reducing the variance of the individual class. It does not focus on any particular instance of the training data. Therefore, the less susceptible to model overfitting when applied to noisy data. So in our decision tree, we are having the main problem of overfitting problem. So this random forest is used to resolve the overfitting problem. And next one is this bootstrapping method is also called as 0.632 bootstrap. That is, we are considering 1 minus 1 by n of the data that is not being picked. So the error we are calculating is 1 minus 1 by n, the whole power n, that is approximately e power minus 1, that is 0.368. So this bootstrap is called as 0.632 because 63.2% of the data will contain approximately the training data. So what is out of bag error? So in bootstrapping, we are sampling with replacement. So and therefore, we are not get any observations that are used for each bootstrap sample. So we are, and the average of 1 by 3 of them are not used. These 1 by 3 of them is not used is called as out of bag samples, that is OOB. So each bagged predictor is trained on about 63% of the data. The remaining 37% are called as out of bag observations. So we can predict the response for the ith observation using these each of the trees, which the observations was OOB, and do for further observations. And then we have to finally calculate the overall classification error based on the OOB error. So this is the next ensemble method is boosting. So in this boosting, it is an iterative procedure. It is a sequential procedure to adaptively change the distribution of training data by focusing more on previously misclassified records. Initially, we are having n records that is assigned equal weights. Unlike bagging, the weights may change at the end of the boosting round. So first boosting round, we are having some weight, and the next boosting round, we have to change the weight according to the previous training data. Suppose in this original data synthesis diagram, so we are having original data set. We are training with some data, and we are building the decision tree. In this decision tree, we are learning some mistakes from the previous data. So we are adjusting the weighting, and we are creating the adjusted data set, and it is this output is fed to the another input of the next decision tree. So if, for example, if we are having, that is in this example, the round 1, the first value is 7. For boosting round 1, we are having 7. So on the next round, we are adjusting the weight, that is we are decreasing the weight to 5, and the third round we are next to it is input to the next value. So the boosting round can change the minimize the values if based on the previous values. So its weight is increased, therefore it is merely to choose again in the subsequent rounds. Each equal weights are assigned to each training instance, that is 1 by d for round 1 at first. First we are taking the classifier CI is to be learned. The weights are adjusted to allow to the subsequent classifier for the CI plus 1. So we need to more attention for the CI plus 1 because we are getting the misclassified data from the CI. So we have to adjust the weight, and we are giving the input to the CI plus 1. So and so on. We are getting the final boosted classifier C. It combines the votes of each individual classifier. The weight of each classifier's vote is a function of its accuracy. The best example for this most popular algorithm is ADA boosting algorithm. So in this previous topics, what is ensembling method and what are the two kinds of method? One is parallel and the next one is sequential. So bagging and boosting we are discussing. So why we are going for random forest? That is no overfitting. In case of decision tree, it is the problem of overfitting. So in this random forest, we are it is not allowing the overfitting. That is use of multiple decision trees. It can reduce the risk of overfitting and the training time is less. And the next one is high accuracy. It runs efficiently on large database. This is the major advantages of random forest. Instead of using a simple data set, we are creating multiple data sets. That is a large databases. It gives the higher accuracy. For larger data, it produces highly accurate predictions. And the major advantage of random forest is estimating the missing data. In case of decision tree, if any data is missed in the decision tree, means we are not calculating or we are not creating or designing the base tree based on the missing data. But in our random forest, if any data is missed, means we can predict the output based on the subsequent methods. That is bootstrapping subset. Using bootstrap subset, we can predict the output of the missing data. So the random forest can maintain accuracy when a large proportion of data is missing. So this random forest, it is an ensemble method. It is basically designed for decision tree classifiers. It is a supervised learning algorithm in the machine learning technique. It is used for both the classification as well as regression problems. So the random forest grows many trees. That is, what is forest? We can have a collection of many decision trees. That is the ensemble method of unpruned decision trees we are applying to our base model. So each base classifier classifies a new vector of attributes from the original data. The final result based on the classification, that is a new instance, that is called as voting. So in the first decision tree classifier, there may be some output. The second DT2, we are having some output. And so on DTN, we are having some output. Based on these output, we are find out the majority of voting. That is aggregating all the predictions, and we can get the voting. That is the majority of voting. The forest chooses the classification result having the most votes. That is overall vote of the forest, the decision random forest. In case of regression, we are averaging it. It induces two sources of randomness. One is bagging, and the next one is random input vectors. So what is bagging method? Each tree is grown using a bootstrap sample of trained data. Already we are discussed in the bagging method. And next one is random vector method. So at each node, we are splitting the best split is chosen from the random sample of m attributes, that is instead of all attributes. In case of decision tree, we are constructing the decision tree based on all attributes. But in case of random forest, we are creating the decision tree with a less number of attributes. That is the random sample of data with a replacement. That is bootstrapped training data. So in this random forest, it takes the prediction from of all the decision trees here, and finally it gets the final output, that is voting. The majority of the voting is the final prediction. So here the first step one, that is in the step one, the original data set, we are dividing that original data set, the entire data set into n random subsets. That is dividing the data set into subset 1, subset 2, and so on, subset n. The second step, based on this random subset, we are creating some decision trees, that is DT1, DT2, and so on, DTN, using this random selection of data. So the splitting can be done by the CART algorithm. Here we are ensembling with this method. And the next one is next step is each decision tree one output is combined with the another decision tree output, and we can perform the voting operation, that is maximum voting, that is collecting all the votes and predict the final output. So to make the final prediction, that is the final prediction is the one with the maximum vote. For example, in case of suppose if you want to buy a mobile phone, you can ask your friends to recommend which mobile you want. So based on your friends' recommendation, some of them say you can buy this kind of mobile A or B. So something like that, which are all the maximum number of voting, you can choose the maximum voting, that is your final output. So in this algorithm flowchart, first for each tree, choose the training data set. After that, you have to set the condition that holds at each node. If it is yes, calculate the error. If it is no, you have to build the next split. In the next split, how to build the next split means choose the variable subset. For each subset, we can choose the variable. So based on the data set, we can choose some two variables. So applying the sample data and sort the variable and calculate the Gini index at each split point. So here we are using the Gini index for what means here we are applying the CART algorithm. That is, we are ensembling the CART algorithm to create the decision tree in our random forest. After creating that one, if the condition is false, you can split the next split. After creating that one, if the condition is yes, means you have to calculate the prediction error and the program. So in this, each decision tree is constructed using the following algorithm. First, let the number of training cases be n, capital N, and the number of variables in the classifier is m. So we have to pick the specified set of variables, that is we are going to create some sample data set. So m is less than capital M. So we are in the original data set, we are having many number of attributes. Using these attributes, we have to select some selected set of attributes, some selected number of parameters, that is the small m, that is which less than m. So choosing a training set for this tree by choosing n times with the replacement from all n available training cases. That is, we have to take a bootstrap sample, use this bootstrap sample, the number of cases to estimate the error of the tree. So that is OOB. The remaining will be calculated as OOB. That is, if some set is not available in our original data set, the bootstrapping data, in our bootstrapping data, some of the data is missing. That is available in your original data set, but it is not available in your bootstrapping data. So that cases are also be considered for training the data, and you have to find out or calculate the error of the tree and predicting the classes of the particular OOB. So for each node of the tree, randomly choose m variables on which to base class the decision at each node and calculate the best fit based on these m variables in the training set. So each tree is fully grown and without pruning. That is, we are constructing the normal tree classifier, decision tree classifier. For a prediction, a new sample is pushed down to the tree. It is assigned the label of the training sample in the terminal node it ends up. For example, in case of COVID-19 analysis data in the previous example, so if whether it is infected or not, if it is yes or it is no. So this variable we have to, this label we have to be specified in the final output. This procedure is iterated over all the trees in the ensemble, and the average vote of all the trees is reported as the random forest prediction. So how we are splitting means the splitters are chosen according to the purity measure. Whether we are using squared error for regression techniques, Gini index and deviance for classification. Here I am using Gini index calculation for building the decision tree. And how we can select how to select n. So build the trees until the error no longer decreases. The error decreases, no longer decreases, we have to select n. So how to select m? Try to recommend the defaults, that is the total number of n, how to divide them, that is half of them, and twice them and pick the best one. That is for the splitting method. So like CART, the random forest uses the Gini index for determining the final class in each tree. So what is Gini index? The random forest uses the Gini index taken from the CART method to construct the decision tree. The Gini index of the node impurity is the measure most commonly chosen for classification type problems. If the data set is T, it contains example from n classes. The Gini index Gini of T is equal to 1 minus summation of j is equal to 1 to n pj the whole square, where pj is the relative frequency of the class j in T. If you in the training set data set T, we are splitting into two subsets T1 and T2. So we have to calculate Gini of T1 and Gini of T2, and based on this Gini of T1 and Gini of T2, we have to split. We have to calculate the Gini split. This formula is the, so in the subset T1, the total size is n1. In the subset T2, the total size is n2. the total number of available data set is n, means we have to calculate the Gini split is Gini split of t is equal to n1 by n into Gini of t1 plus n2 by n into Gini of d2. So we have to select the smallest split of Gini of t is chosen for best split. So here we are using the simple data set for calculating the Gini index. This is a Abridged data set. We are considering only two parameters. One is home type and the next one is salary. So if the home type is 31, 30, 6, 15 and 10, we are having totally 5 records, and salary attribute, either it is a class 1 or class 0. So in this example, we have to split the node, choosing first we are taking the home attribute, means first whether it is less than 6, that is less than or equal to 6, the first case, and whether it is greater than 6. For the next given example, if there are the more possible splits for home type attribute in the left node range, that is 6, which is less than or equal to x, less than or equal to 31, where x is the split value. So what are the possible splits from the given example? The home type is less than or equal to 6, the home type is less than or equal to 10, home type is less than or equal to 15, the home type is less than or equal to 30, and home type is less than or equal to 31. So taking these home type is less than or equal to 6, we have to calculate the Gini index. First we have to create a table for this home less than or equal to 6. In the previous table, how many attributes are less than 6? Here the 6 is 1, so it comes under the classifier label as 0. So here 1, that is 0 of 0, we have only one class, that is 1. So in 1 we are having no 1, that is less than 6, we are having only one data available in the table. So n1 is equal to 1, total number of capital N is equal to 5. So if the home type is greater than 0, we are having 4 attributes, that is 4 records available, that is 30 and 31 are more than 30 and 31, 15 and 10. So in this class, we are having 2 sets of 0 class and 2 sets are class 1. So we have to calculate the Gini index of D1, that is home type less than or equal to 6. What is the formula? 1 minus summation of j is equal to 1 to n pj of whole square. So here 1 minus 1, the 0, what is the home type less than or equal to 6? 1. What is the total number of records in this less than or equal to 6? 1. So 1 divided by 1, the whole square, plus that is 0. That is if any available classes in 1 for the particular data set, particular record 6 means it is 0. So 0 by 1, the whole square. So final the Gini index of home type less than or equal to 0 is 0. And the next condition for home type that is greater than 6 means again we have to we are creating the table for 0 class it is 2, for the 1 class it is 2. The total number of is total number is 4. So based on this 1 minus 2 by 4 the whole square plus 2 by 4 the whole square, that is equal to 1 minus 1 by 2, that is equal to 0.5. So we have to calculate the Gini split. What is the formula? We are already discussed it. That is n1 by n into Gini of d1 plus n2 by n into Gini of d2. That is already we are in this only 1 by 5. The total number of home less than or equal to type is 1. That is 1 by 5 into Gini of d1, that is 0, plus 4 by 5 into Gini of d2, that is home type greater than 6, that the value is 0.5. So we can calculate the 0.4. The similar way we are calculating for home type that is less than or equal to 10 a split and the tabulated in the table. So here based on the previous example that is less than or equal to 6. The similar way we are calculating the home type less than or equal to 6 Gini of d1, Gini of d2 and Gini split. So based on these all the types, that is less than or equal to 6, less than or equal to 10, less than or equal to 15, less than or equal to 30 and less than or equal to 31. So the less than or equal to 10 value gets the minimum value, that is 0.2671. So we have to choose the split node as the attribute is home type less than or equal to 10. This is the lowest value. But in our random forest, the split at which the Gini index is the lowest is chosen in the value. So for better result, we are choosing the consecutive of the smallest value, that is home type less than or equal to 10. What is the consecutive value, that is home type less than or equal to 15. So we are calculating the average of these two values, the 10 plus 15 divided by 2. The average is 12.5. This is our best split in our random forest. That is instead of using home type less than or equal to 10, we are using home type less than or equal to 12.5. So in this attribute is used to construct the decision tree. This is our first splitter. So the previous table, if it is less than or equal to 12.5 means it comes under class 0. So in the previous example, if it is less than 12.5, we are having it is 6 and 10 or comes under this one, that are belongs to the class 0. And the next one, if it is greater than 12.5, it comes under the class 1. This procedure is repeated for all the remaining attributes in the data set. In this example, the Gini index values of the second attribute salary is also calculated based on the home type attribute. The lowest value of the Gini index is chosen as the best split for the remaining attributes. The final decision tree will shown like this. Home type, it is less than or equal to 25. It is belongs to class 0. It is greater than 12.5. We have to select the next attribute, that is salary. If it is either 3 or 4, it comes under the class 1. If it is if it is 1, it comes under the class 0. So we have to set the decision rules for this decision tree. If it is home type less than or equal to 12.5, it comes under the class 0. That is both the conditions. Both home type is greater than 12.5 and salary is either 3 or 4. It comes under the class value 1. That is class 1. If it is greater than 12.5 and the salary is 1, then the class value is 0. So this is a single tree construction using the CART algorithm. So the random forest follows the same methodology and construct multiple trees for the random forest using different set of attributes. So this is our second example, that is whether we are playing tennis or not. This is second sample data set. So we are what is our first step in our algorithm? So we are going to create the bootstrapped data set. So in this, we are selecting some smaller number of attributes, and we have to construct the sample data. So that is bootstrapped sample data set 1, 2, and then 3. So next one, so creating the decision tree using the bootstrapped data set. So the created decision tree, that is root node is overcast using bootstrap data set. Use only a random subset of variables or column or each step. So we can instead of selecting all the nodes, we are choosing selected set of variables or selected set of columns at each step, recursively splitting the sample at other nodes. It results in a wide variety of trees. These wide variety of trees makes the random forest more effective than the individual decision trees. That is the final output of the decision tree. We are combining all the output and predict the final one. So in this first decision tree, D1 and D2 and D3, so if it is overcast, if it is S means we are playing. If it is not means we have to check the wind condition. If it is weak, we are playing. If it is strong, it is no playing. So this condition can be, these three can be tested to our previous data. Here, overcast. Overcast is yes means we are playing. The first D1, the overcast is yes, we are playing. So here in D1 it is not. In D2, D3 overcast is yes means we are playing. Sorry. If it is wind means whether it is strong or weak. If it is weak, it follows the first table. And the similar way we are checking the decision trees with our previous bootstrapped data set. So in this decision tree, it gives the maximum vote, that is play. This is our final output. In the decision tree 2, we are having the final play as output. In the third decision tree, D7, D8, and D9, the maximum output is play. So based on these recommendations and based on these predictions, we have to finally averaging the vote. That is a majority of vote is play. So in this data set, bootstrap data set, I am not considering the D11 and D14 and D12. These data sets are called as OOB, that is out of bag data set. That is, if the data sets are available in the original data set, but it are not included in the bootstrap data set, that are called as out of bag data set. So in the step 3 and 4 in our algorithm, we have to calculate the majority of voting. So in the here the D9 and the outlook is sunny, the humidity is normal, and wind is weak. And what is the that is what is the prediction of this particular class? So in we are checking it out with the original data set. If it is sunny means in the third decision tree, if it is sunny, whether it is playing on it. If it is overcast, play. If it is not, we are checking with the humidity. If it is low, that is we are playing. So the final output of this, the wind is weak. So the output is yes. So the so in our bootstrap data set, we are having totally 11 11 records are available in our bootstrap data set. So out of these 11, the majority of yes is 7, that is play is 7. So maximum number of voting is 7, and no means it is having a number of 4. So maximum, which one is maximum means the play. So in this case, the majority of voting is play. So bootstrapping the data and using the aggregation to make the decision is called bagging. That is we are already discussed. So how our model is good? That is we have to cross validate the data using the out of bag error. That is out of bag data set in the field day D12, which is not available in the bootstrapped data set. Right. So this one is called as out of bag data set. So we have to run this out of bag sample through our trees, that is lesson tree 1, 2, and 3. We have to check it out whether it is true, whether it predicts the correct output or not. So if it is correctly labeled, it means we are not having any error. If it is incorrectly classified the out of bag samples, then it is called as out of bag error. So the next one is we are discussing about the sample data of COVID-19 data set. The previous examples, we are calculating the Gini index and how we are splitting the bootstrapping data set. Based on that is these using these data, we are already discussed in our decision tree examples itself. So now, based on these Gini index calculations and selecting a sample bootstrapping data set, we are creating multiple bootstrap data sets using this previous data set. Here, I am selecting some four attributes only we are choosing. That is fever, cough, and breathing issues, and chest pain. So we are having lot of parameters included in this data set, and that is body mass, that is BMI, and blood pressure, and sputum production. So we are having lot of attributes in the original data set. I have to segregate some selective fields for our example. So using these bootstrap data set, we are designing the decision tree. So in our example, the COVID-19 data and data sets, systematic symptom as well as asymptomatic cases are possible. So I am constructing the decision tree with the OOB error. So in this first case, if it is breathing issues, if it is yes, it is infected. If it is no, it is not infected. This is the first case. And the next one, if it is fever, if it is yes, it is infected. If it is not fever, it is not infected. So what is the final output of it? Final output of this particular decision tree is not infected. So in the next case, the decision tree 2. So if it is breathing issues, yes means it is infected. If it is not, we have to check for the chest pain. If it is yes, again we are going to check the fever. If it is yes, it is infected. If it is not, yes, it is not infected. So the chest pain, it is no, but it has fever means it is infected. So normally, whether we are considering the fever, it is infected. So based on these conditions, we are designing the second decision tree, that is D2. The maximum majority of vote for this particular decision tree is that infected. And we are considering the third decision tree, that is breathing issues. We are comparing it with cough as well as fever. So the majority of vote is that is infected. So combining all these outputs, we are find out the majority of vote. That is the first decision tree we are having not infected, and the second decision tree we are having the output infected, and the third decision tree we are having the output infected. So the majority of voting is infected. This is our final prediction. These sample data sets can be implemented with the help of Python, that is explained by Mr. M. Kannan sir. And what are the advantages of these random forest? In decision tree, the main problem is overfitting. So it is the main advantages of this random forest. It overcomes the problem of overfitting by averaging or combining the rest of the decision trees. So it works well for the large range of data items than a single decision trees. It gives less variance or moderate variance than single decision trees. It is very flexible and possesses very high accuracy. Scaling of data does not require in random forest. It maintains good accuracy even a large proportion of data is missing. That is, it is best best uses of classification for out of bag data set. And what are the disadvantages of these random forest? It is complexity in the main disadvantage of this random forest algorithms, and it needs more computational resources are required to implement the random forest algorithm, and less intuitive in case when we are have a large collection of decision trees. The prediction process using random forest is very time consuming in comparing with another algorithms, because we are creating many number of decision trees. It takes some time to compare with other algorithms. And what are the application, that is use cases of random forest? We are using remote sensing, that is using in-game devices to acquire images on the surface. That is accuracy is higher and the training time is less. On object detection using image browsing, or the object detection is very easy. Combining with the random forest algorithm, multiple class object detection is done using the random forest algorithms. It provides better detection in complicated environments. And banking, we have to identify the loan risk of the customers. In healthcare domain, it is used to identify the correct combination of components in the medicine, that is correct components in the medicines, that is, and to analyze the patient's medical history to identify these diseases, whether they are having the disease or not. We have to identify that one using this random forest algorithm. And trading, it is used to determine the stock the future behavior. And then in e-commerce, to determine whether the customer will actually like the product or not, based on the experience of the similar customers, whether they are actually need the particular product or not. Thank you. Any queries? Next, I handed the session to Mr. M. Kannan, sir.
Thank you so much, ma'am. Okay, let's go with the hands-on session. Okay, let me start. So directly we get into the Jupyter environment first. Yesterday we have seen the code for practice with the classification algorithms like naive Bayesian and random forest and SVM support vector machine algorithms. So now we go with our now we can go with our algorithms today's session. For the today's session, first one is decision tree induction. Another one is random forest induction. And and the most important thing is we need to compare what are the algorithms are there, and the major algorithms we have seen the today and yesterday's classes, SVC and random forest and decision tree induction. So the comparison also is there. And first we move to the decision tree induction. You have very clear-cut knowledge about the theoretical session of random forest induction and decision tree induction, the random forest ensemble and decision tree induction methods. First one is the same like that. We need to import our namespaces here. Our namespaces, required namespaces are pandas for reading the files and reading the CSV files, and NumPy is used to perform the pre-processing operations. And we need to work with the seaborne heat maps. And if we need to plot maps, means we may use a matplot library. And here we read the data by means of dataset equal to pd.read CSV dataset and dataset.head, and then the dataset files are readed here. Age, fever, throat infection, breathing, and blood pressure, insulin, BMI details are here. And I go with the correlation matrix here. I'm going to create the correlation matrix, find out the correlation between the parameters, and shown it as heat map. So for that only we use SNS seaborne class. After that, we set X and Y value. First X data set having fever, throat infection. The major issues are considered here. After that, major issues of the COVID-19 data set can be taken as X, and we assign the target value to the Y. And we need, the next step, we need to split the data set into the training and testing training and test samples. I used to use the function train split function by using the package sklearn and the method class model selection. I use 20% of data for test size equal to 0.20. After that, I create classification function here. I call the classification function here decision tree classifier. No, I like to run the code first. Okay. Yes. The default parameter values of the decision tree classifier is displayed here. The default values are criterion equal to Gini, impurity criterion, Gini and entropy, and the number of maximum features equal to none, and the maximum depth we can we can change the maximum depth also. So if I'm going to change the criterion means okay, that criterion changes to entropy, sorry. Yes, entropy, and maximum depth of decision tree is 5. Then maximum features, no need to set the maximum features. Depth is enough for getting the features. Okay. The criterion value is changes to entropy, and the maximum value can be the maximum tree size of the decision tree can be changed. Depth can be changed to 5. Then we fit that algorithm. Okay. We fit that algorithm to the parameters we passed the criterion value and maximum depth. Then we find the classifier accuracy. Is obtained accuracy is 70.77 because very low number of data set is available. Almost the same result can be obtained in this part because we take only 3 values are taken: fever, throat infection, breathing issues itself, so that our random forest and decision tree will give more maximum the same number of accuracy value will be obtained. The number of features obtained from the decision tree is 3. Yes, and our future importance are taken here. Only 3 parameters are chosen here. That's why it will displace the future importances. And here I need to explain with this. Import sk learned or tree as tree, and tree.export underscore graphviz. Graphviz is a wizard used for display the graph of tree. We can able to see the graph also. For example, I would like to go with the folder here. We don't have any tree files here, only the Jupyter notepad files and the dataset files are displayed here. I'm going to run the code. It says some errors, but my environment cannot support the graph wizard, but you can view with the code. Yes, you can obtain the tree file from the code. We can able to view the tree structure. What are the branches are there? What are the left and right nodes are there? What are the nodes? What are the leaves are there? How we make the decisions? The tree will be displayed as a PNG file. That's why it's used here the code tree.export underscore graph is a classifier comma, that the classifier sends the data to the tree structure, and output file can be obtained in the form of tree.dot. You can run with the code, you may get the tree file here. This is an example. This is an example for decision tree induction. Let's we go with our next one, random forest. And finally I compare with the 3 algorithms. Yes, the same code is displayed here. We need to import and we need to read the dataset files, and after that the correlation matrix is displayed, and the same datasets may be used. I changed the dataset and the x value as 1, 2, 3, 4, 5, 6 values, but in decision tree we used only 3 values. Just check. X dataset equal to fever, throat infections, and breathing issue. We may go with the classification with the fever, throat infection, breathing issue, blood pressure, BMI, and insulin. Get the code like, and we may obtain the output. Just a minute. Yes, correlation matrix is displayed here, and we set the data set. Now the training samples are splitted. After that, we go with random forest. Yes, a random forest classifier. The default values of the random forest classifier are displayed here. The most important parameters or criterion, we need to change the criterion, or we need to change the maximum depth, and we need to change the number of estimators equal to 1. What are the number of estimators? What is meant by number of estimators? The number of estimators is different. Define that. I'm going to create a random forest classifier by means of combination of decision tree classifiers. We are going to split the training samples, and we need to apply the number of decision tree classifiers. We need to apply the model, and we get the result. After that, we combine through by means of the voting, so that the number of estimators can be changed. So first of all, change the criterion if need, but no need to change now. Directly we go with the estimators. Estimators equal to 5. Sorry, it should be 10, because the feature warning also gives which data can be used here. I fit the algorithm. The number of estimators, number of trees used is 10, and I fit the algorithm. The same values are obtained. After that, I obtain the score. The same, almost the same accuracy value can be obtained, because very less number of data sets are used here. So, oh wow, change. The number of estimators we can change it to 66.88. We change the criterion first. Okay. Yes, the accuracy value can change it into 68.18 from 66. So number of estimators is 10. We may reduce the number of estimators to 5. So again, it displays 66. So we need to go with the more number of estimators. So 20. Yes, the accuracy can be varied because of less number of data sets we have used for the random forest classifier. Random forest classifier can be give more accuracy when it goes with the large set of data sets. Then the number of features obtained is 6 because we used the 6 features are here. After that, the 6 feature values are. These are the feature importance obtained from the random forest classifier. I'm going to compare these 3 classifiers in the code. Where is it? Comparison. The default values are used, and the default data set can be used, and the default X values can be used for that, so that it displays different categories. I'm only drop insulin here for X value. So okay, we will start with the namespace. I used all the namespaces here. It is not a supported permission. Here, these are the namespace for basic functions, pandas and numpy, and this is for training and splitting function. This is for feature scaling, and these are the classification namespaces: SVC, decision tree classifier, random forest classifier. After that, we go with the performance metrics, and then these are the feature selection algorithms: select key based, chi-square, and variance test code are used here. And I go to the same, go to the patient data set. Okay. Here, the most thing is we are going to replace the zeros first. We don't want to use the zeros values in the blood pressure, BMI, and insulin. So that's why we go with the code. Yes, the features can be extracted by means of variance threshold method. After that, we obtain the feature extraction, the extracted features here. Okay, then the scaling function is applied here by using select k first, select k based, and the chi-square value, chi-square function. Only X value should be dropped with the diabetes pedigree function, and X for feature extraction. After that, I drop the insulin value from the X. Sorry. Okay, I dropped the insulin here, and after that I split the training samples into data set samples into the training and testing in the size of 0.20. That means 20% taken as testing sample, and then after that I go with the feature scaling. Why this place errors? Just a minute. Yes, okay, it will run. We drop the insulin and the pedigree functions. So balances are age, fever, throat infection, breathing issue, blood pressure, and BMI. After that, we go with the classifiers. Both 3 classifiers are used here. First of all, we classify with the decision tree classifier. After that, we go with the SVC. Then we go with the random forest to identify which is having more accuracy. by means of obtaining the confusion matrix here. After that, we displayed the FN score. FN score is not used here. I'm going to compare with the accuracy score by means of the testing and predicted value. So I go with the decision tree classification first. So by using the decision tree classification, I have received the 0.3%, 63% of accuracy here. After that, we go with 64.28 accuracy, and I go with random forest. SVC have received 69% of accuracy. Then random forest received 72% of accuracy. Though from these things, we have used a single data set and single group of X and Y values by means of these algorithms. So this is the way to compare. Someone is asked to the question in the yesterday, how we compare the decision tree classifiers among all the classifiers. We need to compare by means of a single data set should be taken, and single feature selection and feature scaling techniques should be used. And after that, we apply the all the algorithms to that value. From that confusion matrix, we can obtain the accuracy value. From that accuracy value, the best one will be chosen. From these values, the best one is random forest classifier when compared to the SVC and decision tree classifiers. We need not to compare the naive Bayesian here. We need not to compare the C4.5 or C5.4 classifiers here, but C5.4 classifier is the highest accuracy value predicted predicted here. Is there any errors? Sorry, is there any queries here? Queries for the code? Surely I will give you the code and data set to you by using the whole folder can be sent to you all. EX5. Exercise 5 is sent to you all. Okay. The code contains, I will display the code. What are the code I'm going to give to you? The code contains the patient data, and you may work with the COVID data. So COVID data, you may working with the COVID data means it will gives more number of exercises to you, and the code for reading the CSV file and dimensional reduction and other classification algorithms like SVC, random forest, naive Bayesian, and decision tree. After that, I'm giving the comparison for 3 algorithms. I will give it to you surely. Is there any errors? Sorry, is there any queries? Thank you. Thank you so much for all for your kind cooperation. I request I hand over the session to Mrs. Kalaishali ma'am for vote of thanks.
Good afternoon to all. It gives me a great pleasure for proposing the vote of thanks for this wonderful 3-day knowledge sharing workshop on the title Machine Learning with the Python using COVID-19 data analysis. Thank you all. First of all, I thank all the resource persons who take part in this workshop. Thank you, resource persons. I render my heartfelt thanks on behalf of our management, principal sir, vice principal ma'am, and dean academics for their continuous support and real assistance for making this event a grand success. Thank you all. I extend my sincere thanks to our head of the department and staff members of the CSE department for their support and cooperation. Thank you all. I also extend my heartfelt thanks to all the participants from various colleges and university and various states who made this event a grand success. Thank you all. Also, I would like to thank the persons who are working behind the screen and make their technical support and who contributed directly or indirectly for the successful conduct of this function. Once again, I thank you all. Thank you, participants. Now we will share a feedback link in the WhatsApp group. Kindly fill the feedback link. We will mail e-certificate to the individual mail ID. Thank you, participants.